In 1972, in the middle of construction on the most expensive skyscraper Boston had ever seen, 65 glass panels fell in a single nor'easter until over a third of the building's 10,344 panels had been replaced with plywood, and the press named it the Plywood Palace. Then engineers discovered the building also swayed beyond its tolerances, making residents motion sick, while the excavation had been silently destroying the foundation of Trinity Church next door. Then came the decision that ended every argument. All 10,344 glass panels had to be replaced, because the design itself was fundamentally flawed at a scale no laboratory test had predicted. This is the John Hancock Tower, the building designed to disappear, and what happens when the most ambitious glass curtain wall ever built meets a Boston winter. But first, let's go back to when none of this was supposed to happen. This is the John Hancock Tower, 60 stories, 790 feet tall, located at the corner of Clarendon and St. James Avenue in Copley Square, in Boston's Back Bay neighborhood, directly adjacent to two of the most iconic buildings in the city, the Boston Public Library and Trinity Church. When it was finally completed in 1976, it was the tallest building in New England. The architect was Henry Cobb of I.M. Pei & Partners. The client was the John Hancock Mutual Life Insurance Company, which wanted a new headquarters that would make a statement in the city's skyline without overwhelming one of its most beloved public spaces. That constraint became the design. Cobb's solution was elegant in principle and radical in execution. The tower would be a pure parallelogram of mirror glass, its reflective surface designed to absorb its surroundings rather than impose on them. The sky, the library, the centuries-old red granite of Trinity Church. The building would not compete with Copley Square. It would reflect it. On a clear day, the tower would almost disappear, replaced by a 790-foot mirror of everything around it. The most ambitious idea in the brief was also the most fragile one, a skyscraper designed to be invisible. The glass system was the entire building. Libby Owens Ford manufactured the panels, insulated double-pane units with a reflective coating on the interior surface, each sealed with a lead solder strip between the two panes. The system had been tested. The architects and engineers were satisfied. Ground was broken in 1968. The building designed to become invisible would instead spend years as the most visible architectural disaster in American history. To understand how a glass curtain wall fails at scale, you have to understand what a glass curtain wall actually is and what it is being asked to survive. A curtain wall is not a structural wall. It does not carry the building's vertical load. It hangs on the outside of the structural frame like a skin. Its entire function is to enclose the building and manage the three forces that attack every exterior surface simultaneously: wind pressure, thermal expansion, and water infiltration. At 60 stories above Copley Square, those three forces are not mild. Boston sits on the Atlantic coast. Winter nor'easters arrive from the northeast with sustained winds that load the facade from every direction. Between winter lows and summer highs, the exterior temperature differential on a Boston building exceeds 150 degrees Fahrenheit over the course of a year. Each glass panel expands and contracts with every thermal cycle. Over the life of a building, each panel undergoes thousands of those cycles, each one imposing microscopic stresses on every seal, every connection, every edge. The double-pane insulated units in the John Hancock Tower had a lead solder strip running between the two glass panes. In laboratory testing, the units performed correctly. What the laboratory test could not fully replicate was the specific combination of barometric pressure changes, thermal cycling, and wind-induced building movement that occurs at height on a Boston winter day. Under real-world conditions, the lead strip between the panes would begin to buckle. As it buckled, it broke the seal. Once the seal was broken, the unit lost its structural integrity. The pane would bow outward under wind pressure, and then it would fall. This is the original sin of the John Hancock Tower. Not a failure of construction and not a failure of supervision, a failure of testing. The gap between what a panel could withstand in a laboratory and what it would face in practice multiplied across 10,344 panels on a building standing in one of the most climatically demanding coastal environments on the East Coast. The first panels fell during construction. By 1972, plywood replacements were already going up. Nobody yet understood how far it would go. Nightmare number one arrived before the building opened its doors. In January 1973, a nor'easter hit Boston. 65 glass panels fell from the building simultaneously. They shattered across the streets and sidewalks of Copley Square below. The surrounding blocks were cordoned off. Plywood sheets replaced the empty frames. Then more panels fell in the next storm. More plywood went up. At the height of the crisis, over a third of the tower's 10,344 glass panels had been replaced with flat gray plywood boards. The most expensive skyscraper in New England, a tower designed with the specific intention of reflecting its surroundings and disappearing into the sky, looked like it had been boarded up for demolition. The press had a name for it immediately: the Plywood Palace. It appeared in every newspaper in the country. It was photographed from every angle. The contrast was impossible to ignore. A 790-foot tower of what was meant to be pure mirror glass, covered in squares of gray wood, standing in the middle of one of Boston's most beautiful public spaces. The building, designed to be invisible, had become the most looked-at failure in American architecture. Nightmare number one confirmed. If a $160 million glass skyscraper losing its panels in a winter storm, while the architects who designed it watched plywood go up on the most prestigious site in Boston, sounds like exactly the kind of story this channel is built for. Subscribe right now. We cover the engineering disasters that the mainstream press stops following the moment the lawsuits get sealed. We don't stop. Now back to the story, because the glass was only the first problem. While engineers were studying the glass failures, a separate structural analysis of the building's dynamic behavior found that the tower had insufficient torsional stiffness. The building swayed, not in the controlled lateral way that structural engineers designed for and dampened with counterweights. The Hancock Tower had a torsional response. It twisted as it moved. The magnitude of that twisting exceeded what the tolerances specified, and it exceeded what residents inside could tolerate. Reports came in of nausea, disorientation, the sensation of the floor moving underfoot on windy days. The building was making people motion sick. Two separate structural failures, glass and structural dynamics, discovered one after the other, on the same building during the same construction window. The engineering solution for the sway was two tuned mass dampers, each weighing 300 tons, installed on opposite ends of the 58th floor. The same principle used in Taipei 101. Two massive counterweights mounted on pressurized oil bearings were programmed to swing in opposition to the building's natural motion, absorbing the torsional twist before the people inside could feel it. The installation required opening up the building that was already under structural review for a completely separate failure and inserting 600 tons of counterweight into the top floors. Two failures, two separate engineering interventions, on a building that had not yet opened. Nightmare number two confirmed. Then came the third one, and it was the oldest problem of all. Trinity Church was built in 1877. It is a National Historic Landmark, one of the most recognized pieces of American architecture in the country, a Richardsonian Romanesque building in red granite that anchors the western edge of Copley Square. It was already a century old when the Hancock Tower site was still being excavated. The building Henry Cobb designed specifically to reflect Trinity Church in its mirror glass had, during that same excavation, been slowly shifting the ground beneath Trinity Church's foundation. The earth movement destabilized the church. Cracks appeared in the masonry. By the time the structural damage was formally assessed, Trinity Church required extensive underpinning, a process of drilling beneath an existing foundation and injecting concrete to stabilize ground that had already moved. The repair took years and cost millions. The building designed to honor Trinity Church by reflecting it was simultaneously destroying it from below. Nightmare number three confirmed. Then came the decision that turned a construction crisis into a complete financial catastrophe. The engineering analysis of the glass failure determined that the problem was not in the specific panels that had already fallen. It was in the design of the insulated unit itself, the lead solder strip, the seal geometry, and the way the unit responded to the specific pressure and thermal conditions of this building at this height in this city. That meant the panels that had not yet fallen were not safe. They were simply panels that had not yet reached the failure point. The only solution was to replace every single one of them, not the visibly damaged ones, not the ones near the corners where wind loads were highest. All 10,344 panels on the entire exterior of the building were removed and replaced with new single-pane tempered glass units that did not have the lead strip failure mode. The replacement took years. The additional cost ran into the tens of millions on top of construction overruns already absorbed. Legal proceedings between the building's owners, the architects, and Libby Owens Ford ran for years afterward. The specifics of those settlements were sealed. The plywood stayed up until the new glass was ready to go back in. Nightmare number 4. The building did not need repair. It needed a complete exterior replacement, at full scale, after construction had been declared substantially complete. The John Hancock Tower finally opened in 1976, 8 years after breaking ground, with new single-pane glass on every surface, with 2 300-ton tuned mass dampers on the 58th floor, with Trinity Church stabilized in the ground beside it, with the plywood gone and the mirror surface restored across all 10,344 panels. The press that had spent years photographing the Plywood Palace began photographing the completed building and writing that it was beautiful. The reflective glass that the lead solder strip had made catastrophic was now, in its replacement form, doing exactly what Cobb had designed it to do, reflecting the sky, reflecting the library, reflecting Trinity Church back at itself in a 790-foot mirror. The building that was supposed to disappear had survived everything it could generate and arrived, finally, at invisibility. In 2000, the building was sold for $910 million, then the highest price ever paid for a single office building in the United States. It is now called 200 Clarendon Street. It remains the tallest building in New England. It appears in architecture textbooks. It has won major awards. It is considered one of the defining buildings of its era. Both things are true about the John Hancock Tower. It is one of the most beautiful glass skyscrapers ever built in America. And it spent years as the Plywood Palace, a triple failure of glass, structural dynamics, and foundation that became the most documented architectural disaster of its generation. This channel runs these deep dives every week. The buildings that were supposed to make history and instead made a different kind of history entirely. If that's the kind of depth you want in your feed, subscribe before you scroll.